The problem which we are going to do now is called two sum. In this problem, what we will be given is we will be given an input array and we will be given a target. So what we have to do is we have to check inside this input array and we have to return the indices of the numbers which are when we sum those numbers, then if we get the target we have to return two indices of such numbers. Like for here in this example, if we see our input array is 2, 7, 11 and 13. Now my target is 9. If I take 2 and 7 and if I add, I will be getting 9. So I will be returning indices 0 and 1. So this is my problem. For this, what I'm thinking is starting I will be taking the array and I will be checking like first I will keep my 2 as constant and then for 2 I will be checking, I will be adding every other number and I will check if I'm getting my target or not. Like so for 2 first I will add 7 which is equal to 9. Yeah, so this is true. And then for let me change this. Yeah, I can take 11 to 7. So now what I'll be doing is first I'll take 11 and for 11 I will be adding every other number. 11 plus 2 equal to 13 which is not equal to 9. So next I will go to 11 plus 7. Then I will go to 11 plus 13. Now since anything like 11 plus 7 and 11 plus 13 is also not equal to 9 and not equal to 9. Now what I will do is I will fix my 2 and then with 2 I will start and then I will check every other possibility like 2 plus 7 equal to 9. So here I got my answer. So there might be a case that this 7 and 2 are the last numbers. Like let's say here it might be 13 and here the 2 is there. In that case, we have to explore every other possibility. So here what I'm doing is I'm exploring all the possibilities and I'm getting the answer. So this will be my brute force approach. Like so here my algorithm will be first I will fix the first number, explore all the combinations. So let me do this like fix the first number and explore all the combinations. If answer is found, return indices. Else, what I will do is fix second number and find all combinations, and I will repeat the same process till all my numbers in the array are exhausted. So here what I will be doing is I'll be using a for loop I less than array length I plus equal to 1, and here another for loop. Here I starting from 0, here j equal to 0, j equal to I can write j equal to I plus 1, j less than array length, and then j plus equal to 1. So every time I will be checking if I plus j equal to target. If yes, return array of I comma j. Otherwise I will be continuing this. So here my time complexity will be, since I am using a nested for loop, it will be O of n square. And my space complexity, here I am not using any extra space, so it will be O of 1. So this will be my TC and SC for brute force approach. Now, since n square is not a good time complexity for this solution, I am thinking of optimizing this. So how will I optimize? One solution is like, let's see, what 7, 11, 2, 13. So one solution, one optimization which I can do is, yeah. So here I can fix one number. So here like what we need is x plus y is equal to target. So this target is already given to us. So since we are fixing one number, we will also know this x. All we need to find is this y. So my formula will become y is equal to target minus x. This might be the other way also, like this might be like sometimes what happens is if negative numbers are present in our array, then we have to take absolute value. So for now this will work. So the approach should be like this, like we know the target and we know the x, we have to find the y. So x means this number like which we are fixing. So this x will change like, so when I am looping through this array, first the x will be here, next it will be here, next it will be here, next it will be here. So I know the x and y, x and target, now I should know y. And this y should be present in this array. So I should have some kind of a data structure which already gives me all these values. So one data structure which I can use here is a set or a map. I can use any one of them. But before going to this, it is already given for us that all the elements are unique in our input and only one pair will give the target. So there will not be examples like 2, 2, 4, 6, target equal to 6. This type of examples will not be there. If you see here, this 2 and 4 is giving the this 2 and 4 is giving the solution for us, and this 2 and 4 is also giving the solution for us. So here duplicate of 2 is there, and there are two pairs which are giving us the target. So this will not be there. Like these types of examples will not be there in our question. So since this is clear, now to optimize this, first we have to store this element somewhere, and whenever I need, I have to access them in O of one time. Then only my time complexity will not increase, because for looping through this array, I need O of n time. Yeah, I need O of n time for looping through all these elements in the array. So whenever I want to calculate this y, I should be able to access them in O of one time, so that my time complexity will not increase further. So that's why only two data structures are there, such that I can access elements in O of one time, which is a set and a map. We can use both of them in our solution, in our current solution. So I will be using a set. So what I will be doing is, first inside this set, I'll store all the elements. And now, whenever, now I will keep my pointer here, x pointer here, and then I will be calculating y for every x, and then I will check whether this y is there in this set or not. If it is there, then I know that my answer is there. But here, one thing which is stopping me to use the set is, if you see in our solution, our output should be indices, not the values, it should be the indices. So in this case, I can't use a set, and I have to use a map itself, like, because I need the indices which is mapping to this element. So what I can do is, I'll be storing the values as keys, uh, means values in this arrays as keys, and the indices of this arrays as values in this map, like 7 is 0, 11 is 1, 2 is 2, 13 is 3. So now whenever I will check, when I will be looping this x in this array, and I will be calculating y at every step, and then I will check whether this y is there in this map or not. If it is there, then I will directly return the value. I know access index directly from the array, and I also know y's index from here, and I will return them as an array. So if you see, so here I will return 0, 2 directly. So in this case, my time complexity will be O of n, because I am looping through this array only once, and every time while I am looping, I am accessing this map. So accessing an element from a map is O of one time complexity. So this is the combined time complexity, and space complexity will be O of n, because I'm storing all my elements of this array inside a auxiliary data structure map. So this map is taking O of n space. So this will be the optimized solution. Optimized solution. Yep. Now let's code this. So here, first I will be doing the brute force approach. Brute force approach. So here I will be initializing an outer for loop which will start at 0 and will go till the length of the array, and I will be incrementing it by the step of 1. Now I will use a inner for loop and I will initialize it to I, and here also I will go till the length of the array, and here also I will be incrementing it by a step of 1. Now what I need to do is I need to check if nums of I plus nums of j equal to target or not. If it is equal to target, I can directly return. Here my return is a new integer type, so I can return a new integer I comma j. Yeah, now let's run this. Okay, it is missing the return statement. So here, if since we know that there will be definitely a solution present for this, which is given here as the constraints, like one valid answer will always be there. We can return here like a dummy array. Like I can just return a size of 2 here. Okay, one wrong answer is coming. So 1 second. Yeah. Now I got like we are getting 6 and output as 0 0. Why I'm getting this is since I'm starting my j at I, it is taking it as like 3 plus 3 is 6. If you see I and j, if both are present at 3 itself, then 3 plus 3 will be 6 and my output will be 0 comma 0, which should not be the case. So my j should start from I plus 1, and then now it will work. If you see it is accepted, if I submit, it is submitted. But this is the brute force approach. So let me go back and implement the optimized approach as well. Like let me reset this. Now inside in our optimized approach, what we are doing is we are creating a hash map and storing all our array elements inside the hash map first. So first I'll be creating a hash map of type integer and integer. I'll call it as map and it will be new hash map. Now what I have to do is I have to store every element and its corresponding index in this hash map. So I'll be looping through my array, which will be nums dot length I plus equal to 1. And what I have to do is I have to store it inside the map, like map dot put like array element as key and index as a value. Now what I have to do is after I stored everything inside the hash map, now I will loop through the array nums.length j plus equal to 1, and now I will be using the formula, like what is that formula? Y is equal to target minus x. This is the formula which I have to use. So I already have my target and my x is nums of this I. So what I will be checking is if map dot get of target minus nums of I, then is equal to, means if map dot get of target minus nums of I is not equal to null, means there is something, like means there is some element which is means there is some element which is satisfying this condition inside the map. Now what I will do is I will return new int of this map dot get of this thing and my I, and outside I can just return a empty array. Hmm, let me run this. Okay, I have used I and I have used J here. So let me run it again. Okay, again the same thing is happening. So what it's happening is here also, like since I'm storing 3 here beforehand, while I'm checking this, since 3 is also already present there, I'm getting this error. So what I have to do is first I have to let me take this map dot get outside. Let me call it y. Int y is equal to this thing, and it will be easy for us. Yeah, this will be y. So y not equal to null, and my y is should not be equal to I. Then only I can do this thing. So let me run this. I think this should be -1. So now this is accepted. Let me submit this. Okay, what it is telling is if I use y like this, here uh, since that value itself is not there inside, it is giving us a null pointer exception. So we have to fix this also. So these are like a common mistake like everyone can do. So what I will be doing here is, instead of doing this, let me use this condition itself, and instead of so let me change this to target minus nums of y, and instead of doing get here, I can just check for if the map contains key itself or not. So map dot contains key, and y, since my y has uh, the target minus x, so if it is there, then the key will be there, otherwise it won't even be there. And here I can do map dot get of y directly, and here I can do map dot get of y, and let me see if this will work. Yeah. So here it's accepted. Let me submit this. So this worked. Now here I did this thing in two passes. Like first I'm storing everything in map, and then I'm checking whether it is there inside the map or not. Instead of that, we can do everything in a single pass. So how we will be doing that is, so I will be removing this condition which I don't need now. Here itself I will be storing. So first I will get the y value, target minus nums of y, and now what I will do is, first I will check if that value is there in my map or not. If that value is there, then what I can do is I can directly return this thing. Otherwise, what I will do is I will do map dot put that value and the current index inside the map. And now if I run this, okay, let me see what error I'm getting here. 0 1 0 0 1. So this is also a common mistake. This is also a common mistake which people will do. Here what I did is, if you see, I'm getting 0 0, but why I'm getting that is, here I have to store not y. Y is my target minus nums of i's value. So here if you see, if my I is 2, 2 minus, sorry, target is 9, 9 minus 2 is 7. So y will be 7 here. This key is not there inside. So now what I am doing is, I am putting 7 at 0th position. But what, instead of 7, what I should put is, I should be putting 2 here, because 2 itself is not not there inside the map. So that mistake I did. So now I'll be rectifying it. No, so it will be nums of I. Now let me run it. So this ran successfully. Now I have to submit this. If you see, this passed successfully, and the time and space complexity are, time complexity is often and space complexity is also often. Now we did this only in a single loop here, if you see. Okay.